So, not sure. I've- Oh, there we are. Okay. So, um, I'm starting a little bit later than what I said. Oh, and I still need my. So, I've been wanting to do for a while, and that jump into it. I want to do live streaming office hours. My students ask questions. I'm gonna start by today. I'm just going to go over a bunch of stuff for my trigonometry class, my calculus class, but um, by the end of the week, I should have my schedule set up so that I can send, I can have regular office hours online. That link. I'm not sure how to find a link for live stream where I start. But once you find the channel, you should send calculus class. I don't know that this is regular time for this. By the end of the week, I'll be able to have my schedule down for the rest of the semester, and I'll enlarge this to the rest of my classes. Anyway, I've pulled up quiz one for the trigonometry class and homework one for the trigonometry class, and um, think think I want to start with that. So I don't think I'll get to the calculus by the end of this live stream. I have to teach a class in 40 minutes, but after that class, I will come back. I'll be able to do calculus stuff on the second live stream later today. I have here, this was the homework assignment that we were given in the trig class. So, that up here. So I do want to explain this because I got some questions on it. I said all problems with numbers that are divisible by 4. What I mean is I want you to do chapter 1, section 1, problems number 4, 8, 12, 16, until you get to the end of the chapter. Okay? So I had students ask me, they did all of the problems, and then they asked me if they got the right answers. They thought I meant the questions that have answers that are divisible by 4. That is not what I meant. I meant the problem number. I want you to do number 4, number 8, number 12, number 16, and so on. Okay. And then same thing here. Do the numbers that are between 11 and 30, but the numbers that are divisible by 12. Those will be the 1.3. I want you to do problem 10, that one. And then I want you to do 12, 15, and 20, 24, and 28. And those are all of the ones in that region that are divisible by 4. And then do 31 and 30. That should be that should explain what I mean by that. Okay. I'm not going to show the textbook on the live stream. I don't think that that would technically be a copyright violation, but because I think that this is I think fair use something like transformative um nature of the medium or something like that. But I at any rate I just don't want to worry about that. Plus the textbook we're using is free. The students in the class know what it is and can download it. Students that are not in the class, well, maybe you can somehow reverse search what textbook we're looking at. But I'll tell you what the problems are when we do it. Yes. So let's first look at the quiz because the deadline for the quiz is coming up faster than. I'll pull up the quiz here. So I have question 1 is I want you to fill out the special angles table for our 6 trig functions. So our trig functions are sine, cosine, tangent, cotangent, and you can put them in different orders. As long as you label, even if you didn't label them, I could probably figure out which column is which function. But as long as you label them, put them in the order that I have them on the quiz. There we go. There are functions, and we'll have our argument here. Special angles we'll use are 0, pi over 6, pi over 4, pi over pi over. Now, other angles can be special as well, but usually when you're talking to someone doing trigonometry and you talk about special angles, they're talking about these. But and the reason that these ones are considered special is because they're the ones that are fairly easy to compute using just regular geometry, drawing a right triangle and using Pythagorean theorem. Answers are fairly aesthetically. I'm not going to go through all of these. I do have a video on this on my channel. You go to the trigonometry playlist. There's a video that goes through calculating all of it. But all that question is you want to fill out the entire table. So sine of 0 is 0. Sine of pi over 6 is a half. Next one is 1 over square root 2. Square root 3 over 2. And 1. If you fill out all 30 of these values, that's that question. There's a little bit of formatting stuff at the bottom. Make sure that you type it in a way that the recognize. Don't type it in a way that the computer recognizes. Do the quiz as many times as you like until you get a score that you're happy with. Until the clock's. Anyway. Next question is fill out the table indicating which trigonometric functions are positive, which trigonometric functions are negative in each quadrant of the plane. So, again, in the video in my trigonometry playlist that talks about the definitions of trig functions, I mentioned that if this is an angle theta and this is a length of 1, this is a right angle. This triangle is what's the basis of our trig functions using modern definition. The ancient Greeks used slightly different definitions, and I think I mentioned those in my video. But the x-coordinate of this point we call cosine of theta. The y-coordinate we call sine of theta. From here, we define tangent to be equal to sine. So tangent theta is equal to sine theta divided by cosine theta. That is this side divided by that side. Now, looking at this, we know that both x and y are positive in quadrant 1. That means sine and cosine are going to be positive in quadrant 1. And then tangent is a positive divided by a positive, so it's also positive. So in quadrant 1, the functions that are positive will be sine, cosine, tangent, and then cotangent, cosecant, and cotangent, cosecant, and secant are all reciprocals of those. If you take a positive number and take its reciprocal, that is to say 1 over that number, you end up with another positive. So that means that cosecant, secant, and cotangent are also positive in quadrant 1. In quadrant 2, y is positive, but x is negative. So that's going to switch our cosine to be negative. That one turns negative, and its reciprocal is secant, which will also turn negative. Tangent will be a positive value divided by a negative value. The tangent will become negative as well. And its reciprocal cotangent, that is not what I marked as. Flip the also do. This is the one that cotangent. Cotangent with C in it. That'll be negative because it's the reciprocal of tangent. So that means that just sine and cosecant are going to be positive in the second quadrant. Quadrant 3, we have y is negative and x is negative. That means that we're going to have sine and cosine are going to be negative in quadrant 3. So this is quadrant 2 here, quadrant 3 under the x-axis. And so, but tangent is sine over cosine, so tangent will be a negative divided by a negative, and that's positive. That'll be positive in quadrant 3. Cotangent's the reciprocal. It will be positive in quadrant 3 as well. The other ones will be negative. And quadrant 4, we get y is negative, x is positive. That means that in quadrant 4, we get cosine secant be our positives, but all of the other functions will end up being negative. So you might see people do all are positive, cosine and its reciprocal secant. So all are positive in quadrant 1. Cosine and its reciprocal are positive in quadrant 2. Tangent and its reciprocal are positive in quadrant 3. And sine and its reciprocal are positive in quadrant. You might see this chart used to help you with. I have a video on my trigonometry playlist about using the unit circle special angle. Use the special angles chart together with this chart in order to find all of the special angles on the unit circle. So that uses a technique that's called reference angle. So 3 terms that you should know would be reference angles, supplementary angles, and I'm hoping my spelling is correct on that, and complementary. I'm pretty sure that an I there means compliment, like telling someone something nice, and an E means complement, which means the other part of a thing. So I'm pretty sure that that's right. But reference angles are the smallest angle to get back to the x-axis. So if I have an angle like this, my reference angle is from there to the x-axis. If I have a reference angle that's like this, then that's the shortest way to get back to the x-axis. It does not matter if I'm looking at the positive x-axis or the negative x-axis. That's the way to, like, I'm just seeing what's the shortest turn I can make, the smallest turn I can make to point in one of the two sides of, point in the same direction as one of the two sides of the x-axis. Supplementary angles, two angles are supplementary if they add up to 180 degrees. So this angle is supplementary to this one because they add up to a line. Complementary angles are angles that add up to a right angle. This angle is complementary to that one. The reason why cosine is called cosine is because if we're looking at this angle and this height is the sine of the angle times the length of the hypotenuse, call it h for hypotenuse. So this height here from this point down to the axis is h sine x. Then cosine, this angle here, or this side here, is going to be h sine of the complement of theta complement of theta co-complement, where we get the cosine. So if this angle is theta, then this angle is 90 minus theta, and this here becomes the opposite of 90 minus theta. So therefore, this becomes the hypotenuse times the sine of 90 minus theta. So this is equal to h cosine of the co and cosine, and the co and complement are related. So question 2 is we're going to fill out that chart about where functions are positive. Question 3, we're going to talk about converting radians and degrees. So in every circle, there are 360 degrees around it. But we also know that the radius, whatever that is, r, we know that the distance around the circle circumference equals 2 times pi times r. So what we could do to measure angles is measure, well, how many radii are we going? If we take this distance from the center of the circle to the edge, walk around the circle that far, we say that that's 1 radian worth of angle. So, circle, here's the radius, whatever that radius is, I decide to walk that far around, walked 1 r around the circle, this angle is 1 radian. And that means all the way around the circle will be 2 times pi times the radius. There are 2 pi radii around. We call the angle that goes with that distance around the radian. So that means that 2 pi radians equals 360 degrees, because both are all the way around the circle. And if I cancel a 2 from both sides, I get pi radians equal 180 degrees. So if I'm given an angle of any type, if I'm given an angle in degrees, say 95 degrees, if I multiply that by, there are two, well, let's use, there are pi radians in every 180 degrees. Those are the same thing. Top and bottom of the fraction are the same, so I'm multiplying by 1. So I don't change the value of the 95 degrees, canceling the degree. I see I can cancel a 5. 5 goes 80, 30 times. Yeah. And then 5 goes into 95 19 times. So I get 19 pi over 30. Oh, that radians is equal to the original 95 degrees. And I've converted from radians. Try it the other way. If I have some number of degrees, let's say I have, the 7 pi over 6 radians. I want to multiply that by, I know pi radians equal to 180 degrees. Multiplying by a fraction that where the top and bottom are equal is just multiplying by 1. It doesn't change the value. But I can do cancellations to change the form. 6 goes into 180 30 times. Pi and pi cancel. 7 times 30 is 10. The symbol is not canceled. This is 7 pi over 6 radians converted to degrees. Okay, so that should be question 4 on the quiz. Question 5. We have 2 legs of a right triangle and we want to find sine. So let's take a look at that. If I have 2 legs of a triangle, as A is 4, what is sine of A? So this is side little a, this is side little b, this is angle big B, this is big A, angle C. We're going to let that. And then this side C. Well, sine of A is going to be the, the opposite side is over here. That's 4 over the hypotenuse. I don't know. But we can use the Pythagorean to figure it out. Pythagorean theorem is a squared plus b squared equals c squared. I plug in my numbers. 4 squared plus 4 squared equals squared. I get 16 plus 16, which is 32 squared. So c equals the square root of 32. I could factor this. 32 is 16 times 2. Square root of 16. 4. So that means that my sine equals 4 over 4 root 2. Cancel my 4's. Get 1 over root. Go. Same idea for question 6, but you're looking for not too bad. If A and B are supplementary angles and A is 175.3 degrees, what is B? Well, just remember which one is complementary, which one is supplementary. The supplementary, they add up to 180. So to do that problem, we have the two angles have to add up 180. Subtract 175.3 sides, 4.7 degrees is my other angle. Complementary is the same, but instead of adding up to 180, they add up to 90. Oh, here's another term that we need. Coterminous. So co with terminus means so coterminous angles are ones that have the same ending. I have this angle, and I also have this angle. They end up in the same spot. Okay? So angles are coterminous if their difference is a multiple of 360 degrees. So if I start off with an angle of negative 151 degrees, I want to find the first angle that is coterminous with rotating positively counterclockwise. So I have an angle that's negative 151. That means it is more than negative 90. There's negative 90. Here's 0, negative 90. It is more negative than that, but here's negative 180. So negative 151 is somewhere in here between negative 90 and negative. If I add 360 degrees to this, I find the next coterminous angle. 60 plus negative 151 is the same as 3 minus 151. Borrow minus 1 is 9. 5 minus 5 is 0. 3 minus 1 is 2. So the coterminous angle we are looking for is 0.9 degrees. As a rule of thumb, if you're asked a question in degrees and you're not told to change to radians, give your answer in degrees. On the other hand, if you're given an angle in radians and you're not told to leave it in radians. So whatever form you get it, you should leave it that way. Answer. Okay. Last question on the quiz. A certain tree is 11 feet tall, casts a 22-foot long shadow. At the same time, another tree is casting a 53-foot long shadow. How tall is the second tree? We assume that the angles that the trees make are the same. I'm drawing them as 90, but this technique works as long as the two trees are pointed in the same direction. Most trees point up. But we would have a problem if our trees were one tree. Then not be able to. Okay, so we have this. We want to figure it out. These two trees these two triangles are going to be proportional. The sun is going to come in at this angle. That's why the shadow is where it is. And it's going to come in at the same angle over here. This angle and this angle are the same. If you have two angles that are the same that on two triangles, that means you have three angles that are the same on two triangles. So these are similar triangles, meaning that the ratio of this x divided by 53 has to equal the corresponding side, which is 11, divided by the side that corresponds to 50. We can simplify this fraction. So x over 53 equals 1/2. I multiply both sides of the equation by 53. to cancel the denominator. X equals 1/2 of 53. It's going to be 26.5. And that's our answer in feet. Although, for the purpose of quiz on Canvas, I don't want you to write feet. That your answer will just be 26.5. That's all the time that I have for now. I'm going to be back in a little over an hour after I teach my class. I will see you later. I hope that was useful. Will probably work on calculus. Might do some review trigonometry. I also need to schedule a live stream. Recalculus and college algebra function classes. Okay. Later.